Okay. Um, what we'll do today, how about just a review session, or do you want me to lecture some more? I'm done lecturing. Okay. So let's do the review session first, and then we'll, if you haven't done them, one of the things we've started to do is I now get emails every time a PGEE section reaches 30% completion of the evaluations, 40% completion of the evaluations. And I've noticed since I sent out the email about extra credit, I told you the response, the completion rate has been going up a lot. So anyway, we're still not at 75%. So what I'd like to do today after we go through the review session, if you haven't done the annual evaluation of the course through Moodle, and I think I sent you a link that you can hopefully use on any of your devices. I don't know if it works very well. Does it work pretty well? Yeah. Okay. So if you've done that, you can use that. And of course, then we also, unfortunately, we had you do written evaluations of the lab, right? Well, there was some miscommunication, but we also, did you guys get an email about a Google Forms link? Okay. So I'll put that up and how you do this. And then there's another thing that you do through the HHMI. Did you get something? So I'm sorry to, all education right now seems to be about assessment and surveys and things like that. So I'll show you, and I'll send you a link to this other thing we'd like you to do. We have this big Howard Hughes Medical Institute grant, and PGEE is one of the courses that we'd like you to sort of evaluate. And I'm not sure all of you get that, but anyway, at the end I'll show you what I'm kind of looking at. Okay. So the exam is going to be very, very similar to the format of the other exams. There's going to be 15 multiple choice questions. What I would really focus on there are really, in each of the lectures, really focus on any sort of examples and graphs and data where I spend a fair amount of time looking at a graph or data and those sorts of things. So that's what I would focus on. Okay. Okay. So a lot of the multiple choice questions are kind of, what's the result of this? What was true about this particular, like the mangroves and salt, right? What's the major outcome there? What was true in that study? Those sorts of things. So that's what I would primarily. There are a few sort of questions, that are just basically what's a definition and what, a term that you'd have to pick out. So there'll be a couple of those. Be one multiple choice, and then there are going to be two sort of problems. You know what those are, right? It's going to be a demography problem, right, where you have to calculate. I'm going to make it real simple. All you're going to have to calculate small r, right? Okay. So, and then interpret what accounts for the differences in R between two populations by looking at the age-specific fecundity compared to the survivorship. So kind of like what we did. I haven't decided. I might have you plot the survivorship curves and the fecundity curves, but I haven't decided yet. So that's one of them. What's the other one? Isoclines, okay? So I'll give you probably one or two examples with numbers and ask you to plot those, tell me the outcome, plot the trajectories of the population sizes of species one when they're both below the isocline, and then what's the final outcome? Does it go to a stable equilibrium, or all those sorts of questions, okay? And then I might as well just tell you. What I would really think about for one essay is we've spent a lot of time talking about, in a lot of different things, whether it's the snowshoe hare lynx example, right, or the stuff we did on community structure, is understanding processes that involve top-down control, right, like the predator driving the prey numbers, or bottom-up control, okay? So that's been a big theme throughout this part of the lecture, so you can imagine one of the essays is going to focus on that. I'm not going to tell you what particular examples, or it may be something completely different, and having you use your knowledge about distinguishing what kind of data can be used to distinguish, top-down control of community structure or all sorts of things, or bottom-up control of things, right? And think back to the example of that fish, zooplankton, phytoplankton. That was kind of one of the examples. Also, there were plenty of other examples that we used where predators seem to drive sort of diversity at lower levels in both the things they eat and the plants that they eat. So that'll probably be one of the primary. That'd be one of the questions. Okay. I'd say, I think it's, I haven't quite finished it yet, so I think it's fairly straightforward. Okay. Of course, that's me. Okay. So I'm happy to entertain any questions you have, I've got some isocline problems that I could pop up and ask to do. Do you want me to do that? Okay. I forgot my iPad today, so anyway. I've been waking up at 4 in the morning every day recently, so I'm kind of a little scattered. I won't tell you why. Okay. Well, that's not it. Can you see that pretty well? Okay. Let's look at that one. Okay, if you get a question like this on the third exam, right, stop before you start calculating numbers. And you should be able to, this is a little more difficult, but one of the things I would do first is I would look at these competition coefficients first, right? And that should tell you what's the most likely outcome here, okay? So if you were to look at this example, and it's a little more complicated because K1 and K2 aren't exactly the same, so I'm not saying that's all you can do, okay? But what do you think's going on in this situation? Yep. And how do you know 1 is more competitive over 2? Yeah, so look at the alpha and beta, okay? So remember alpha, what's that? You have to remember, that's the effect of which species on which? 2 on 1, okay? So that's a low value, it's below 1, so that suggests in general that species 2 is having a weak or minimal competitive effect on individuals of species 1. Beta is pretty high, which means that's the effect of what? 1 on 2, and that suggests 2 seems to be a superior competitor. So what do you think the outcome is going to be when you do that? What's the arrangement? What's the arrangement of the isoclines going to be? Yep, 2's always going to win. And is its isocline going to be intersecting with 1, or is it going to be above and parallel to it, or below and parallel to it? Above and parallel. Okay. So let's actually. Unfortunately, I don't have the. So what do we need to do? Do I have any chalk? Okay. What's the first thing you want to do in all these cases? Solve the equilibrium points. 2 of them are easy, right? And what are they? Okay, so I don't have a calculator. K1 over alpha. Can somebody do that? K1 170 over, well, I can do that. Okay, I should be able to do it. What's that value? Huh? Okay. I don't need a calculator to do that. Okay, and K2 over beta is 100 over 2.5, which is 40. Okay? So what do we got? N1 is along here. N2 is along there. So where does K1 alpha go? That's going to be 340 up there, right? Well, you don't necessarily. You should plot this. And then what's K1 goes to what? 170. So connect those two. Okay. And then what's the other line? K2, where does that go? Which axis? On the y-axis. No. Remember, this is species 2, so K2 goes on this axis, and it's below it, right, because it's 100. So that's K2, that's K1 over alpha, okay? And then where's the other one? K2 over beta is down here, because it equals 40, and there's that, okay? So what's the outcome? That's the species 1 isocline, that's 2. Do you get a stable equilibrium? Yep. Where does it go when it enters that space? Where does the population size go? Nope. So it goes to that, huh? Okay. So let's look at this. Now so below this, right, you're below both isoclines. What's the, when you think about these zero growth isoclines, right, when you're below them, what's the relative growth in the population sizes of both species in this example? It's positive, right? So this is basically saying it's kind of a vector that, you know, numbers of species 1 are increasing in that space and also 2, right? It's kind of going up for both. Okay, so yeah, so now what's happening, you now have crossed the species 2 isocline, right? What happens when you're above a species isocline in terms of its population growth rate? Is it positive or negative? It's negative, okay? You're still below the species 1 isocline, right? So it's positive, right? So the way to think about this, of course, that what's happening, now you're above the species 2 isocline. Remember, this is the number of species 2, right? So it's declining, it's going down. So in this space, the numbers of species 2 are going down, right? And the number of species 1 is going up, okay? So the key you really have to think about when you're above and below an isocline, you get different population growth rates. Yeah.
Can you show us an example of
when it's going up?
Yeah.
Okay.
I think we have one from the lecture.
Okay. When it's going up for, okay, where it goes to a stable equilibrium in the middle when 2 of them are crossed?
I think so.
Okay. Okay. I mean, I can draw a bunch of different combinations of things, and what I thought I'd do is I'm going to leave these 2, and I'll send this to you via an email, and I'll have you you can do these 2 as practice, right? But if I were to ask you on that bottom one, what do you think the outcome is there? What do you think it is? And this is what I would always do as you go through these problems, start looking at the numbers first before you, and then if you get a result that doesn't seem right, seems counterintuitive to what you predicted before, just looking at the competition coefficients, you might have done it wrong, okay? So one of the things I would do is I would sort of do this, and if you want to work in groups, do it all independently, right? And then give yourselves 5 minutes to do, and then see if you all get the same answer. And I'll post the answers, but don't look at the answers, then try to do the problem, because that usually doesn't work. Okay. So what do you think the outcome is going to be on that bottom one? What's that an example of? Yeah, it's going to be stable, but what are those competition coefficients telling you? Yep. So they have weak competitive effects on each other. They're more limited by interactions between the members of the same species. They're very limited competitive effects. They're not interacting or competing with one another at all. It's below 1. So what do you think the isoclines, how do you think they're going to be arranged? Parallel or crossing? They're going to be crossing, and the outcome will be species coexistence, where they're crossing and they go to that stable equilibrium where you have both numbers, you have both species A and species 1 and species 2 are maintained in equilibrium, okay? Do you want to, I'm not going to do that. Okay, so go ahead and I'll post that on Moodle. I'll send you an email with an attachment, then you have to go to Moodle. So you can do those problems. Okay. So again, a couple things, just look at the competition coefficients first, right? And they'll tell you something. I'll make it fairly simple. I'm not going to mess around with K1 and K2 a whole lot, being very different from one another, because it can, but, and then just remember, just memorize what the equilibrium points are. K1 over alpha and K2 over beta, and then be able to plot them based on the solutions. Okay? How's that? Is not too difficult, or is it a little puzzling? Not too bad? Did the lab help you? Did it? Okay. Okay. What else? Demography? Okay. What questions do you have about demography? How to do the problem? Okay. So the key, also, if you didn't pick up your homework, come get them afterwards. Okay, so you can look at that, and I posted that. So the demography solutions are in they're on Moodle in the week where I have the demography PDFs and recordings. Okay, so I think I remember which week. Okay. Okay. So what are the things you got to remember? What things am I giving you? LX and BX, right? And what are those? And I used to be really mean, let me tell you. I used to give you like actual numbers and then you had to calculate the survivorship, and then I gave you the total number of offspring they produced, and then you had to divide it by the number of surviving individuals to calculate BX, and so anyway, I've gotten softer in my old age. Okay. Well, I found what it was, it was a lot of memorization, a lot of steps, and it really didn't meet what I was trying to get, which was you to try to learn something. Okay. I'm still not sure I'm getting you to learn all this stuff, but hopefully okay. So what do I give you? What are the things you got to know? I'm going to give you the age, and again, I'm going to give you an example. It's not going to be this. I'm going to give you an example where I'm contrasting two populations, right? And I'm going to ask you to calculate the population growth rate parameter. It's going to be small r. It's going to be just like this, okay? And what I'm going to ask you, you're going to look at, well, is one R higher than the other, and what can account for that? And you have to look at the survivorship curves and the fecundity curves to understand that, kind of like we did with the Mediterranean rabbits. Okay, Mediterranean and arid Australian rabbits. Okay, so a lot of it's just pure memorization, right? And the key things is just remember these things, right? Those are the two columns you need to calculate from the data. Just multiplying each part, taking LX times BX, right? Gives you that for each age. So you just have to go through all those. Then you sum all those, right? And this is the other one. So down there. And then what's the other column? By X, by the age, okay? So all you take to get that is 4.5 times 0.22 times 1.8 gives you that value. So you have to calculate LX, BX for each age category in each population, and X, LX, BX. Okay. Do you want me to give you this formula? Okay. Okay. Well, I'll give that. I think it's I'll give that formula to you so you don't have to remember how to calculate small r. You will have to remember, though, how to you have to determine what's R sub O, right? I didn't make that in subscript. And then what's T, okay? So where you take unfortunately, it should be the logarithm of R sub O, right, divided by T, okay? So where do you get R sub O? Which value is that? Huh? Yep. So this is R sub O, the sum of all these values in the LX, BX column, okay? T, what's that? What's that kind of a measure of? It's called the generation time. Yeah. Yeah. It's actually, this is calculated as this sum divided by that sum, okay? So it's x, the sum of that column x, lx, bx divided by the sum of the lx, bx column. So 26.9526 divided by 2.5, whatever, okay? And that comes out to about 10 point, that basically what that's saying is this is kind of the average age at first reproduction or the average generation time at which individuals start reproducing in that population, okay? So what you'll notice here are these two populations differ in terms of the time at which they're first reproducing. Which one's reproducing earlier? Yeah, the Mediterranean population, okay? And you see that in the fecundity, right? When you did those, so, okay. So when you do all those calculations, you take the log of R sub O divided by T, R equals 0.09 in this population, and R equals 0.06, okay? So that's fairly close to zero, right? But would it be positive population growth just by its absolute value? Yeah, it's above zero. So remember, small r, if it's greater than zero, means there's going to be a positive population growth rate. This is pretty much zero, pretty stable. Yeah. Whatever, ln, whatever that is. Is that the natural log? Okay, yeah. Just look at your calculator. Yep. Okay. Yep. You want to know if we're going to have to calculate profitability, and you might also have to determine if the predator should specialize on the most profitable prey or generalize. Okay? So let's, so then from that, so something looks weird here, right? Here's something that, which population survives at a much lower rate, especially early on? Look at those LX columns at the same age. Which ones has higher mortality or lower survivorship, especially to 4.5, to 9, to 15? The Mediterranean population, right? Its survival rate 22.2%, 0.16%, 7.5%, up to 15 months. Whereas the other one's about 30%. What's causing that? Probably the mosquito and the myxoma, the virus that's much more common in the Mediterranean populations. I just made this up, but I don't know if this is true. Whereas the arid populations, mosquitoes aren't as prevalent, so the myxoma is not around as much. So this may be sort of a parasite causing a lot more mortality in the Mediterranean populations. So they have really much lower survivorship, and you look at the curves, and the Mediterranean population's curve is much below the arid population. How do they have a higher population growth rate? It's 0.09 versus 0.06. How do they compensate for that? Yeah, they reproduce earlier at a much higher rate, right? So they're reproducing in 10 months on average. Their age of first reproduction is much sooner, and look at their average number of offspring produced at 9 months or 15 months. So they have this big peak in early higher birth rates, and then compared to the other population. So those are I realize this is a fair amount, but kind of break it down into the. And so those are the curves. And what you'll see, the BX, the Mediterranean, has that huge, much higher value of early age fecundity at 9 and 15 months to compensate. Okay. And that sort of ties back to life history, right? Did we talk about life history in this? Okay. Okay. Forget about it then. Okay. Okay. So those are going to be the two problems that you'll have to do on the exam. Any questions about that, or anything you want me to elaborate upon further? Yeah, I haven't decided yet. It might be. I'm trying to figure out timing and how long everything's going to take, right? So. I may have you graph them. Probably will help you to answer. It probably will help you to answer the sort of verbal part of the the questions where I ask you to interpret. Okay. And again, if you just get them, it doesn't have to be exact and perfect. Don't be real anal about, making sure it's exactly, 8 point, just so the curves show that one of them has pretty, it's probably going to have different survivorship, and there's going to be compensation and fecundity. It's probably what you'll see. Okay. Okay. So was the question about profitability, was that supposed to lead to something? Okay. Yeah. That's not going to be a problem, but it might be a multiple choice question where you have to do, it'll be pretty straightforward calculation. And so what do you have to know about profitability in determining whether something should be specialized upon or eat both? What do you need to do first? Determine the profitability of the two prey items. How do you do that? Yeah, the energy content divided by the handling time of each one. Okay? And then what? So you got E1 divided by H1, then you got E2 divided by H2, and let's say you figured out the first prey item was more profitable. It had a higher energy gain per unit time of handling. Now what would you do? You have to add in the search time of which prey? Yep, of the most profitable one. So from this, if you know that's the most profitable one, right? You then take H1, whoops, I don't need to do that, plus S1, right? And what do you do next? You see, is it greater than E2 over H2? So just set up that inequality, solve for those, and see, if the left side of the inequality is greater than the right side of the inequality, what would you predict the predator should do? Specialize and only eat the most profitable prey. If E1 over H1 plus S1 is not greater than E2 over H2, then that would lead to the expectation that they should eat both. They should specialize or generalize. Okay. So again, that's just sort of, again, I don't give you the equation for this one, so you have to memorize that one. So just kind of think about the steps. I'll give you the energy content and handling time and the search time for all the prey items, right? And then just go from there. Okay. Anything else? Yeah, top-down control versus bottom-up control. Think about the snowshoe hare lynx example. Somebody tell me, what are we interested in the snowshoe hare lynx example? What pattern are we trying to understand? Yeah, oscillations, right? And these fairly predictable, what we call time-lagged oscillations, where over an 8 to 10 year period, you go from often high peak abundance of the prey to another high peak abundance of the prey, and often the peak abundance of the predator is slightly later than the peak abundance of the hare. The lynx is not exactly right on top of it, okay? So that's the kind of the thing we're interested in. What we're interested in is what drives those oscillations. So in top-down control, what would that be? Who would we say is driving that? Yeah, if the predators are driving those oscillations, right? And again, go back to those predator-prey isoclines, right? And you go through this cycle where you go through these phases where you'll go from low abundance of a prey to high, down to low. That's one cycle in that isocline graph, right? And do you think there might be an isocline, a predator-prey isocline graph as part of a multiple choice question? Okay. So you might think about understanding just, what happens in each one of those quadrants, right? There are 4 of them, and in which does the prey decline and predator decline, or when does the predator increase and when does the prey decline, and understanding what happens in there. So if you think about top-down control, what we're basically saying is the predator is driving these oscillations, right? What's the bottom-up control hypothesis? Huh? Well, not that the prey are driving it. There's something else below the prey, the snowshoe hares. Resources, right? And especially what do rabbits eat, or hares? Vegetation, right? And they eat primarily grass, low-lying grasses, shrubs, things like that, and where they live in the northern regions. So they're herbivores, right? So another option, of course, is that it's the plants that are driving and the primary force in causing these oscillations. So when you think about it, how could plants drive sort of the oscillations, and the predators just might contribute to it or exaggerate it, but aren't the primary drivers, but might just sort of go along with it, right? So how could plants drive? Let's say, why might hares increase rather exponentially, right, from low abundance to high abundance over about a 3 to 4 year period? That might have something to do with, yeah. That's at peak, that's at low hare abundance. There's a fair amount of vegetation that's regrowing. There may not be a lot of sort of herbivore pressure on the plants to produce secondary chemical compounds and things like that. So they might go through an exponential, it's a little more complicated than that, but they might go through a sort of exponential growth because of access to plentiful resources. As the hares reach a really high density, what do you think happens? Yeah, more limited resources, and that could be either due to just reduced biomass, just reduced amount of vegetation, or it could be sort of plant defenses and production of secondary chemical compounds in response to high herbivory. Okay? And the idea would be that basically they're driving it, and the lynxes are just kind of following along, right? And as the hares go up due to plentiful plant resources, the lynx eat them, right? Then they reproduce and lag, but then as the populations decline due to the plant shortages, then the lynx follow it. Okay? That would be bottom up. So the idea here is top down means these higher trophic levels or higher levels in the food chain or food web, right, are driving the interaction. So think about that. Remember the phytoplankton, zooplankton example I did at the end, right, where we showed that when fish were introduced, they had a major influence on the zooplankton, reduced it, and then the phytoplankton went up. That would be an example of top-down control. But there's another, the other possibilities could be phytoplankton are driving it. So it kind of depends. You can get lots of different results. So depending on what kind of groups you're looking at. So again, top-down means they're higher. What's another example of a sort of top-down control that we talked about right at the beginning of this section of the course? Yeah, the strawberry. Yeah, but even before the mites and strawberries. How about sea otters and sea urchins and kelp forests? Okay. So so this is peppered throughout the entire, is looking at interactions between these, what we call different trophic levels. For the top of the food chain or food web versus the primary base or primary, which is the bottom, okay? Anything else? Have you gone through the study guide? Kinda? Okay. Are those study guides helpful? Seriously? Okay. I never got them when I was an undergrad. Not that I probably would, I shouldn't say what I would have done. Okay. Is that it? Anything else? Okay. If nothing else, why don't we go, you want to go ahead and start doing some, if you've done the evaluation of me, that's good, right? But I also, let me just show you, let me kind of go through. Let me ask you if you've seen this stuff. And so what's the motive? Did you get something like this? Okay. And yeah. Right here. That's a plus. Yeah, you sum the handling time and the search time of the most profitable prey. Yep. Yep. It's a plus. So you guys got this? Okay. Can you just do this out of the goodwill of your heart? Because I don't think I can track the completion rate of this one as easily, right? So if you can, take some time to, so we want to be able to evaluate the TAs separately for me, and I know you did the hard copies, but testing, the university won't do those forms anymore, so now we have to do these electronic evaluations. So if you can, if you wouldn't mind doing that. And you'll get that from Carolyn Noyes, and she's the associate provost. You got it? Okay. So yeah. Is it a pretty easy evaluation? She says a minute or two. Okay.
I did it while you were lecturing.
Oh, okay, good. So you weren't paying attention to me. Okay. I'm going to make everybody turn in their devices so you can't have access to anything. Okay. So that's one of them. So if you could please do that, I'd really appreciate it. And also do so the web star evaluation is just of the lecture part. So do that. And some sections are at 40%. So can't remember which sections. So what if we get to 75%? What happens? Bonus points. So it's all on you. So what I need, what I'd like to, I'll tell you, the deadline will, I need to compute the grades for the third exam by, and your final, what your grade would be without taking the final, and I have to you're going to get those back on Tuesday, a week from today. So basically, I think the deadline's going to be, I'll say Friday or probably Friday to finish these on the evaluations of the class to get the bonus points. I'll put that on the third exam is what I'll do. Okay? And then let me ask, so just go ahead and if you want to do those now and get it out of the way, that's fine. That would be great. And then did you get anything from Aubrey Roy? Did you ever see anything like this? And again, who knows? It was entitled UNO STEM Scholars Post-Survey Spring and 2014 Course Evaluation. A bunch of times? Okay. So I'm just asking you out of the goodness of your heart if you would try to. So a lot of what for these big sort of national grants with the Howard Hughes Medical Institute, we have sort of assessors. She's from UC Riverside. We were one of 37 universities nationwide to get one of these, and let me just tell you, we were the only one in Louisiana, and all the other universities were, I'll just say, tier 1 universities. So we're really trying to do some new things in some of the curriculum in the math, biology, and we're going to be meeting with the HHMI people to come in and try to expand this to other parts of the sciences curriculum. So they're coming in tomorrow to talk to me. So we really like to have these assessments of how the courses are doing and these outcomes. And these people at UC Riverside are really good at this sort of thing. I don't know how long does it take very long to do? Is it kind of a longer one? Has anybody done this? Okay. A while back. Okay. I don't know. I think these were, when were these sent out? Do you know? Do you get bombarded all the time? How often? Like every?
Like at least every.
If you do it, you don't get them, do you? You do?
It
Ooh.
took me from showing you that, and then I did it real quick, and I'm just done.
Okay.
So
Oh, it doesn't take that long. Okay. So I'll send this out as an email if you wouldn't. I mean, I know we're not going to get a 75% response rate because I can't offer you any incentives, but anyway, if you wouldn't mind doing that, that would be great. Okay. So I'll send all this stuff as an email at some point, but okay. All right. Anything else? So we don't need another review session, do we? Is this good enough? I'm kind of booked tomorrow, so, okay. All right. Oh, well, you want to do an eye clicker and attendance, and that'll be the last one, okay? And then I'll be able to determine your attendance grade. Okay. Yeah, if you have any questions or things come up, if you have real specific questions you want to answer during email, or if you want to come in and talk to me, that's fine. We can set up something too. Okay, thanks. Oh, okay.